This lesson is about using the Pythagorean and tangent identities. They're written in blue in the page. We'll just see how they come about for starters. If we have our unit circle diagram, we know that this point is cos theta, sine theta. So if I call this A, this B, and this C, using Pythagoras, I should be able to develop the Pythagorean identity. A is cos theta all squared, B is sine theta all squared, equals to 1 squared. Whenever I have cos theta all squared, I write it as cos squared theta. So the squared before the theta doesn't mean cos theta, that means cosine theta times cosine theta. I get cos squared theta plus sine squared theta equals 1, which is my Pythagorean identity. Sometimes, as we'll find later, it's useful to be written in terms of sine squared, and sometimes it's useful to be written in terms of cos squared. These two alternate forms are found just by rearranging that equation. We do have another one, tan theta equals sine theta and cos theta. From the point of view of this angle theta, my opposite side is sine theta, my adjacent side is cosine theta. That's where that one comes from. So I'll go ahead and see a few different ways we can go about using these ratios, these identities. Here's one. If we're given a sine value and we know that the angle is between those two values, we should be able to find the following without actually solving for the angle. So for part A, trying to find cosine, I know sine. This is my known. I'm going to substitute into sine squared theta plus cos squared theta equals 1. And I'm going to solve this for cosine theta. Sine squared theta means 0.4 squared and I can rearrange for cosine squared. Now I get cos theta, I need to take plus or minus square root. I'll end up with cosine theta is either plus or minus 0.92. I've got two solutions, but I'm going to reject the negative. Okay, as theta is in quadrant 1. This thing here is telling me that the angle theta is in here somewhere, where I know that cosine is positive. I know that all the ratios are positive. Alright, part B, find tan theta. Well, I'm going to use the tan theta identity since I know both of these things. I know sine theta and I know cosine theta. And I can just substitute these two values in. 0.4 divided by 0.92 gives me the fact that tan theta is 0.43. So I can find all those ratios without actually having to find the angle. Part C, how would your solution change if theta could be any angle? Okay, well, we would have two solutions. So two values of cosine theta, and therefore two values of tan theta. Because the reason we rejected that negative one was because we had limits for our angle. Okay, a real reason why you'll probably use these identities more realistically is in simplification of trigonometric expressions. So when we're simplifying, we want to have the least amount of ratios, so least amount of sines and cosines, and the lowest powers. You'll have to be able to add, subtract, and simplify fractions. You might need to remember how to factorize, and definitely going to need to use those identities. So I'll do question 1 as a demo. I've got 1 minus cos squared x. I know that I can replace cos squared of an angle with 1 minus sine squared of that same angle. So I'm going to replace cosine squared with 1 minus sine squared x. If I do my expansion, so I've got 1 minus 1 plus sine squared x, which equals sine squared x, which is what I'm after. All of these problems will require some little trick. Okay, I'll write down the little hints here. So there's a tip for each one. Take the expression, do true things to it all the way down, and try and make it look like these answers. I'd recommend going down to question 4, and then doing question 7 and question 8, and then going up to 6 and 5. Just the level of difficulty that I think there is. There's also some additional questions in exercise 6D that you can have a go at. Good luck.